Hey everyone, Katrina here, and today I'm going to tell you everything you need to know about trig ratios. Be sure to subscribe for more videos and watch to the end to see the examples. Okay, so this video is super important for trigonometry. It's going to tell you how to find the relationships of the side lengths when you have a unit circle, when you have a triangle, and this will help you calculate your angle and often find an exact answer, so you don't have to rely always on approximations. So we're going to go through the trig ratios for the three main trigonometric identities as well as their reciprocals. So we're going to be relying on this image that I have right here circled, and we're going to be referencing it and annotating it as we go along. So following our typical XY axis, we're going to start labeling this. So we're going to call this length over here, we're going to label that as our X side, because that's the side that falls on the X axis. Then we're going to go and we're going to label this side over here. Oops. We're going to label this vertical side over here. Oh, sorry about that. It disappeared on us. This vertical side over here that I'm highlighting, this is going to be labeled as our Y axis. And then lastly, oops, grab that side back. And then lastly, this side over here, our hypotenuse, is going to be labeled as R. And the reason why it's going to be labeled as R is because you can think of it as a radius of our unit circle. So if we were to extend out this whole line, if we sweep it out, we're going to get this like full circle that has a radius of R. So that's why we are calling then our hypotenuse our radius. So that's going to be our terminology that we're going to use here, and you can see that this triangle ends up being a right angle triangle, so it has a degree 90 degrees right over there, and that's really important. So when you have a right angle triangle, that means that you can use SOH CAH TOA. So if any of you have heard of SOH CAH TOA before, that helps you figure out your trig ratios for if you have right angle triangles. So the first part over here, it says that sine theta equals to opposite over hypotenuse. We have cos theta equals to adjacent over hypotenuse, and then tan theta equals to our opposite over adjacent. So we're going to update these ratios, and we're going to write it using in terms of our x, y, and r, which is more representative of our unit circle. So that means that sine theta equals to y over r, cos theta equals to x over r, and then tan theta equals to y over x. And then now we can use that and reference our triangle here. So these are what I would call our primary trig ratios. So now let's think, what are our reciprocals? So reciprocal means that you take 1 over your existing value. So what is the reciprocal of sine? So 1 over sine theta equals to cosecant theta. We have that 1 over cos theta equals to secant theta, and 1 over tan theta equals to cotangent theta. So what does this mean in terms of our trig ratios? How can we find cosecant, secant, and cotangent in terms of our x, y, and r? And that's actually pretty simple. All we have to do then is reverse these trig ratios right over here. So that means now that our cosecant theta is going to equal to r over y, our secant theta is going to equal to r over x, and then our cotangent theta is going to equal to x over y. And there you have it. We have our 3 primary ratios right over here, and then we have our 3 reciprocal ratios. So these are our 6 main trig ratios that we need to use in order to solve for our angle. So this is a really great bank of information. I recommend before any trig test that you have to actually write down these like ratios really quickly at the top of your page so that you don't forget them, because they're key to solving trigonometric equations. Okay, so let's dive into just like a little bit of an example so we can see this in action. So let's say that we want to find, we have sine theta, and this is going to equal to, let's say, 1 over root 2. And we want to find what is theta. And whenever you're solving for theta, think of it as like when you're solving like a polynomial, for example, or a different type of equation, that you're solving it on a specific domain. Do you have an infinite domain, or do you have a specified restricted domain that you're solving on? Trigonometric functions are periodic, so that means that they repeat on their period towards infinity, both in the positive x and negative x direction. So that means that in order to avoid writing an infinite amount of solutions, we usually have to specify where we are going to be looking for our specific answer. What is our domain? And just for the purpose of this example, and to relate it back to our unit circle here, we're just going to restrict our answer to fall in this first quadrant where our triangle is over here. Okay, so we're going to say that theta has to be between, let's say, has to be greater than 0 and less than or equal to 90 degrees. Okay, so that means we are restricting it specifically in this quadrant right over there, because our angle would start from 0 over here and then it goes to 90 degrees right over there. Okay, so let's see what we can do. So sine theta, if we look at our ratios over here, we know that sine theta equals to y over r. So let's go ahead and write another unit circle out and kind of place those values where we have them. So like we said, we know that our radius value is going to be root 2, and our y value here is going to be 1. Okay, and we want to figure out what is this angle over here. So the one way you can do it if you want to plug it into your calculator is you can simply take the sine inverse. So how do you find angle? How do you detach sine from the theta? Well, simply you would just do that theta equals to sine inverse of our side length ratio of 1 over root 2, and you'd go plug that into your calculator, and that would be one method to solve this. You get a value of 45 degrees. But I'm going to show you another method that actually does not rely on using your calculator. So this is where we get into the territory of what are known as special triangles. So I have another video on special triangles, so be sure to consult that. And these are triangles that have specific ratios that we can rely on. So in this case, we have this triangle over here that has root 2 and 1. And knowing my special triangle, I know that this side length must also be 1, and this angle over here has to be 45 degrees. Because this is an isosceles triangle, and we know the total internal angle of a triangle is 180. So if we have a right angle here and 90 there, that must mean that this angle here is also 45, and these two side lengths over here must be equal. So that is another way how we can solve for it being 45 right off the bat without even plugging that into our triangle. And then we would get that our angle here, theta, on the interval from 0 to 90 degrees is equal to 45 degrees. So we were able to successfully solve for our theta. So what I really want you to take out of this video is just understanding these trig ratios, because they're really crucial for you to solve for all your angles when you create them around your unit circle. Please stay tuned for more videos. I'm going to have a lot more information on trig coming up, as well as how to solve more complicated trig equations, as well as proving identities. So make sure that you subscribe for more, and I'll definitely see you next time. Bye.